Good morning, pre-calculus class. This short video is to start putting the two ideas of composition of functions and inverse functions together. If you look in your student text, your student workbook, Module 3 Investigation 4, I think that's part B, and you'll find this problem number 3 given two functions f and g, where function g takes its input as its input the side length of a square and outputs the area of a square. So here's function g. Inputs the side length in meters and outputs the area. And then there's a second function, f, that takes as its input the side length of the square, but then outputs the perimeter of the square. So function f is the second graph. Input side length of a square in meters and output the perimeter of a square in meters. Scoot this up a little bit so we can just see the graphs and the questions. Okay, so this puts composition of two functions into context, and we're asked, does the expression f applied to g of 4 have a real world meaning? Okay, we want to show that this answer would be no. Okay, and we start by looking at the input for f, which is g applied to 4. Okay, so 4 would be the side length of a square, and g applied to 4 would be the area, 16 square meters. I'm writing off to the side, sorry about that. I have to get used to my equipment again here. Okay, so looking again, the input that we're trying to evaluate for f, g of 4 would be 16 meters squared and is an area of a 4 by 4 square. Can we apply f to g of 4? Can we apply f to 16 meters squared? Well, 16 is a value of area, but the input to f needs to be a side length. So this is undefined. We cannot evaluate f at some measurement for area. We have to evaluate f at some measurement of side length of the square. Then our publisher changes the order of the composition in part B. Does the expression g applied to f of 4 have meaning in this context? So it's all contextual, and that's what I want you to see this morning again. So this answer is no. If we start inside of the composition and look at f applied to 4, we don't have a problem. 4 in this case would be a side length, and f of 4, let me see if I can bring this down where we might be able to see the graph. So this is function f. F of 4 takes us to a perimeter. Well, that's interesting. So that's 16. But that would be in meters. Yeah, think about a 4 by 4 square, and if we were to travel around the perimeter off here, almost off the page, we'd travel 4 plus additional 4, and another 4 would be a total length around the square of 16 meters. And contextually, can we then evaluate g of 16 meters, where 16 is a value of perimeter? No, we need side length. So it's not just the units that matter, but the quantity that it matters what the input quantity is. 16 here, down here at the bottom of your screen, is the perimeter of this green 4x4 square, and that is not the input quantity to G. Okay, we'll pause here. We've seen two examples of where the new composition functions, f composed with g and g composed with 4, did not have defined output, so the composition did not make sense in this context.